Hello and welcome to the 7th video in our lecture on remote user authentication. In previous videos, we discussed how to implement authentication using hash functions first and then symmetric encryption. In this video, we're going to see what we can do with asymmetric encryption. And in particular, can we use asymmetric encryption or public key crypto to do the authentication of one user to another? So remember that the setup in public key cryptography is that every party, every user, and in particular Alice, has a pair of keys. So she has a public key and she has a private key. And because this is true for every user, we're going to subscript those keys by an A to indicate that those are Alice's public and private keys. So can we use this setup to authenticate Alice to Bob? The answer is yes. At least we have a proposed mechanism here. So let's see how this works. So in the first step, Alice is going to send her identifier to Bob. So she initiates the communication. Bob will pick a random number of nonce, and it's going to encrypt it using Alice's public key. So Bob is going to send this encrypted version R prime of the nonce that he picked. Alice, receiving this response from Bob, knows that it's a challenge to her. This is still a challenge response mechanism. So she's going to respond to the challenge by building the response. And the response will just be to take R prime and to decrypt it using her private key. Okay, and whatever she gets, of course, is going to be R because that's what was encrypted in the first place. So she gets the response, which happens to be the decrypted or plaintext version of the nonce, and this will be sent to Bob. And Bob will be convinced that he is indeed talking to Alice because if Alice sends her or sends him the original nonce that he has sent in an encrypted form, then he knows that only Alice could have been the one to decrypt it because only Alice knows her private key. So I want you to think about this mechanism, and I want you to pause the video and make sure you can answer all of these questions, or that I think, or at least you think really hard about the answer to these questions. So the first question we already answered. Alice is indeed authenticated to Bob in this scenario, and the reason why is because Alice is the only one who can produce the response since she's the only one who knows that private key. Are replay attacks prevented? Hopefully you thought about this and you came up with the answer, which is yes indeed, as long as this R is a true nonce. If it's a real random number and that number is only used once in any type of application of this protocol over time, then replay attacks are prevented. So make sure you understand why Trudy could not impersonate Alice and replay this exchange. And the reason she can is because in a future exchange during a replay attack, this R that Bob generated would be different. And so Trudy would not be able to fake the response by sending the old response to a new challenge. The next question is this protocol an example of encryption or signing? Remember that in a public key crypto system, one of its powers is that you can use it in two different ways. Someone can use it to send a confidential message to Alice using her public key to encrypt it, and then she can decrypt it with a private key. Or it can also be used for signing, in which Alice signs a message with a private key and sends it to someone else who can then verify the signature using her public key. So is this an example of the first scenario or the second one? Well, from the perspective of Alice, this is really an example of decryption. So it's an example of the first type of application because what she's doing here is she's using her private key to decrypt an encrypted message. So this is indeed what appears to be a secure protocol for authenticating one user to another. Have you come up with any ways to break the system? Is there a problem with this mechanism? If not, make sure you pause the video again and you try, and I'm going to discuss one such problem. So the problem is that using this protocol, Trudy, the attacker, can get Alice to decrypt any message that Trudy picks. So what do I mean by that? What I mean by that is that whoever sends a message to Alice, this protocol asks Alice to decrypt it and send the decrypted version of it. So one attack that Trudy can perform is a person in the middle attack, right? So Trudy can sit here in the middle, quote unquote. And so basically what she could do is she can intercept the first message, the authentication request from Alice. She's going to notice that Alice wants to authenticate herself to Bob, so she's going to intercept this message. Then she's going to pick a message that, or maybe she's going to capture an encrypted message that Alice had sent to someone else in a previous communication protocol. So let's say that Trudy has access to a ciphertext, something that was encrypted with Alice's public key that someone else was sending to Alice, some confidential message C. Then what Trudy is going to do is she's going to send that encrypted message C to Alice, and Alice will think, pretending to be Bob, of course, Trudy going to pretend to be Bob. Alice going to think, oh, this is a challenge from Bob. Bob is asking me to decrypt this encrypted nonce, as Alice believes it to be, even though it's really an encrypted message that Trudy intercepted from someone else. And then Alice is going to send the decrypted version P of this message to Bob, but really Trudy is going to intercept it, and she's going to get the plain text corresponding to the ciphertext. And so this is a very bad attack, right? Because again, if we have another party, Charlie, that's using this key pair to send an encrypted message to Alice so that Alice can later on, well, actually, she wouldn't send it back, right? If Charlie was trying to communicate confidentially with Alice, it would encrypt his message using Alice's public key, send that to Alice, and Alice would be able to recover the uh, plaintext using her private key. But what happens is, what if Trudy is listening in on this communication early on and she just captured that ciphertext? Then she can do a person in the middle attack on this authentication protocol and get Alice to decrypt that ciphertext for her, which obviously is not a confidential message anymore. And the reason she could do that is because Alice was thinking that this was Bob and she was trying to authenticate herself to Bob. And with this person in the middle attack, Trudy could abuse it to do a decryption step. So, what is the lesson here? The lesson here is that you have to be very careful when using public key cryptography. If you have a key pair that you're using for authentication purposes, like in this protocol, you should never use that same key pair to doing confidential messaging with someone else. So what does that mean? That means you should always have two different keys or key pairs. You should have a key pair for confidentiality, and you should have another pair, P prime, that is used for confidentiality. So sorry, you should one key for authentication and one key for confidentiality. So that way, Trudy would not be able to perform this attack because Alice thinks she's doing an authentication here. So she would use this key pair in that scenario. But for the green scenario, Trudy or Alice would have used a confidentiality pair. So there's no way that Trudy could actually use one key uh, and so one message encrypted with one key and get it decrypted with the corresponding key. There would be a problem right there. So this is kind of a subtle problem with this technique, but again, the solution is simple. We don't have to change the protocol. We just have to make sure that Alice uses one key pair for authentication and another key pair for confidentiality. And this is true of every user in public key cryptography. So just another variation here. Notice that we said that from the perspective of Alice, the previous authentication mechanism looked to her like basically a decryption step. But could we actually make it look like a digital signature? And the answer is yes. The way to do that is a simple modification. After Alice sends her identifier to Bob, the challenge that Bob sends to Alice now is not an encrypted nonce, but just a regular nonce, plain text. So Alice just to authenticate herself can simply encrypt it with her private key and then send that back to Bob. And so then Bob can use her public key to decrypt it and see that what he gets is whatever the original nonce was. So therefore, Alice is the only one who could have decrypted it or encrypted it with her private key, same thing. So in this scenario, it's still Alice that's being authenticated to Bob. So this is really just an alternative scenario or protocol for the authentication of Alice to Bob. And of course, this also solves the replay attack problem because of the random number or nonce that is used. And what is the difference between this protocol and the other protocol? Is the difference is that Alice, to accomplish the last step in this protocol, she had to encrypt this message using a private key. So as far as Alice is concerned, she did the same thing, right? So she did encrypt or use a private key to process this message, which is exactly what she did in the previous protocol. But what she's really doing is she's encrypting the message. Therefore, she's signing it. This is why it's an authentication mechanism. Whereas in the previous protocol, she would use a private key to decrypt it. So it's more of a decryption side of things. But eventually, she was using in both cases the same private key. So is this a difference? Is it not? It doesn't really matter. The point is, this is another way to use asymmetric or public key crypto to implement a one-way or single user authentication. Now, you have to be careful. You have to realize that the problem that this technique has or this protocol has is the flip side of the problem in the previous case. For the same reason, Trudy can still do a person in the middle attack. But in this case, what she can do is she can do this attack not to get Alice to decrypt anything, okay? But by impersonating Bob in this case, Trudy can get Alice to sign anything that she wants Alice to sign, even if Alice is not happy to do that. Because again, in this protocol, or in this version of the protocol, when Alice gets a message, she automatically just signs it. That's what she has to do. So if she Trudy can get in the middle and get to send a random message to Alice, she will get a signed version of that message. So the solution again is the same as before. Simply use a different key pair for this protocol, which is used for authentication, and for whatever other key pair you would use for the other use um, of public key crypto, which would be for confidentiality. So the problem is the flip side of the problem on the previous protocol, but the solution is essentially the same. So this wraps up our discussion of the use of asymmetric cryptography to implement a secure authentication protocol, and in particular a remote user authentication problem.